In this video, I'd like to talk about memory sizes. Now, memory sizes for computers, everything starts with just a bit. And a bit is either a 0 or a 1. And that's it. It's either on or off. And this comes from the hardware of our computers. It comes from electricity, and it's either on or off. It's charged or not charged. It's also where sometimes you see power buttons that look like a 1 or a 0. It looks like IO, and that's where that comes from. It's either on or off, right? The next unit of measurement that I want to talk about is called a byte. A byte is equal to 8 bits. Now, a bit being a 0 and 1, we can't really store that much data in there. You could store the value of 1, but what if you want to store the number 3? Well, you can't store the number 3 inside of a bit. You can store a 0 or a 1, and that's it. So we need to use multiple bits to store bigger values. So to store the number 3, we could use binary with 0s and 1s to store that value. Now, a binary number 3 would look like this inside of a single byte. So remember, a byte is 8 bits, so there'd be 4 zeros. And then the second one would be the number 3, which looks like this. That's the number 3 in binary. Now, we can store larger and larger numbers based on these zeros flipping to 1s as they get larger, right? And so we could store bigger and bigger numbers by having numbers that take up more bytes or more bits. Typically, integers are 32 bits. That's where that phrase 32-bit integers come from. So they take up 4 bytes, right? Because each byte is 8 bits. Or you can have 64-bit integers. Well, what about when we want to store something like a character? A character for us as programmers, or a char, or even strings, right? Those are all stored still using bits and bytes. And the way that we do that is we say, you know what, we are going to use this value, this integer value here, this number is going to represent a specific character or a specific letter, right? And we can look this up on what's called the ASCII chart, which is essentially a conversion from specific numbers to characters. If you were to take a number, if you were to take an integer, and in C++ or any other programming language, and you were to kind of just cast it to a character and then print out to the console, you would print out, you'd print out letters, and you'd be doing it based on their numerical representation. Now, one thing that I'll mention really quick is that typically when you write a byte, it is actually broken up into 2 sections like this. These smaller sections, 4 bits, this is actually called a nibble. Don't ask me why, but it's called a nibble. Right? So we have a bit, which is a 0 or 1, a single 0 or 1. We have a nibble, which is 4 bits. We have a byte, which is 8 bytes, or 8 bits, right? After that, then we start getting larger and larger, right? We have a kilobyte. And a kilobyte is 1,000 bytes, right? And here's where the story gets a little complex. A kilobyte, same thing with a megabyte, same thing with a gigabyte, right? Which are the next ones up. So there's a kilobyte, and then there's a megabyte, and then there's a gigabyte, right? These are all equal to 1,000 of the previous number, right? So kilo means 1,000, it's 1,000 bytes. Mega is 1,000 kilobytes, right? Gigabyte is 1,000 megabytes, right? And then after gigabyte, we have terabyte, and then we have petabyte, and then we have exabyte, and then a zettabyte, and then a yottabyte. And there's no way I actually remember all these phrases. I'm just looking at them on my computer monitor right now, right? The only ones I really ever remember are bit, byte, kilobyte, megabyte, gigabyte, and terabyte. That's really the realm that we work in, right? Especially as programmers, we typically work in this realm around here. So one confusing thing. Have you ever bought a hard drive and it says that it's, a certain number of gigabytes, and then when you hook it up to your computer, it's actually less than that, right? If I go look at the hard drives on my computer right now, it might say that they are 1 terabyte, but then when I look at the sizes of my computer, it's actually only like 800 or 900 or something gigabytes. And the reason why is because there's actually a little bit of a naming confusion here, right? So first off, this word kilobyte, kilo means 1,000. That's typical in the metric system. Same thing with mega, giga, tera, so on and so forth, right? Which is why these are representations of 1,000 of the previous units. Well, our computers do everything in powers of 2. So technically, when they're displaying memory, it's based on a power of 2. It's actually 1,024 bytes and 1,024 kilobytes. Now, there's a slightly different naming convention for the proper terminology for these, which is actually instead of a kilobyte, it's a kibibyte. And instead of a megabyte, it's a mebibyte. And instead of a gigabyte, it's a gibibyte, right? So these are actually equal to 1024 bytes. And a megabyte is 1024 kilobytes. And a gigabyte is 1024 megabytes, right? Now, there is one other naming standard, just to make it even more complex, which actually says that kilobytes with a capital B instead of a lowercase b means 1024. This is why sometimes when you look at your internet bandwidth speeds and stuff, sometimes you see abbreviations with a lowercase b, where you have kilobytes with a lowercase b and then kilobytes with a capital B. The capital B typically represents 1024, whereas the lowercase b typically represents 1000. This is a really good example of very confusing naming conventions, because here you have kilobytes that represent 1000 and here you have kilobytes that represent 1024. There have actually been lawsuits about this naming convention specifically, about misrepresentation, about internet data speeds or hard drive speeds, right? So these are the standard sizes that we work with when we deal with memory. When we're talking about individual values, individual variables, we're typically talking about some number of bytes. When we talk about our computer memory, our sticks of RAM, typically we're talking about this realm, gigabytes. And then we're talking about solid storage, our SSDs or our persistent storage, our hard drives. Typically we're talking about terabytes now at this point, right? Someday in the future, we'll be talking about petabytes and exabytes and zettabytes and yottabytes, but we're not quite there yet. Commercial hardware for us as people and our video games that we develop, and our realm is just in this range here.